Good morning, students. Today we are going to discuss about the feature vector, feature space, and we'll talk about feature selection and the feature extraction. So these are the basic terminology of any machine learning model or a deep learning model. So we should know what exactly these are. So we'll discuss one by one all these concepts. So what you will understand with the features first. So feature is nothing but it is a numerical or symbolic property of an object. Take a simple example. Suppose I want to find out the price of a house. Okay, so if I want to find the price of a house, I should know what is the size of the house. So size could be a feature here. Okay, a size can be one feature. The locality where house is available, that could be another feature. How many year old your house is, that could be the another feature. So I want to know about my data set, so I should know what could be the features available in the data set. So I hope it is clear what exactly the feature is. Now we'll talk about vector. So vector, we all know what is vector. Vector is nothing but a series of numbers, or we can say it's like a matrix, but that matrix will have only one column with multiple rows. So what should be my feature vector? So feature vector is nothing but the collection of features. If you are keeping in a vector form, then we'll call it as feature vector. Clear? What exactly the feature vector is? Feature is a numerical information about your data set, that is called feature. Vector is nothing but we are representing those features in terms of in terms of vector, then we'll call it as feature vector. Clear? Now, feature vectors are used to represent numerical or symbol characteristics, which we'll call it as features. We discussed just now. So take another example here. Suppose I'm saying we have a particular object which is of a color image. Okay. And whenever I'm talking about a color image will always have a three properties, three description, which is called red, green, and blue color description. So this color red, green, and blue description we are representing through a feature vector. So I represent in this way. So this will represent, if I'm saying the value is 133. So 1 is representing red color value, 3 is representing green color value, and we 3 again representing blue color value. So this is nothing but my feature vector, which is consisting of a color coding of green, red, and blue. Fine. Now we'll take a one more example, so better you will understand what exactly the feature vector is and how it's playing an important role for machine learning. So here we have taken the four examples. Suppose I'm saying I have a document. I want to know what are the features I can take from this document and what could be the features available in this document. So if I'm saying this is a document, so document could have a number of words. So suppose here saying number of words are 173. The same way this document, I want to know that how many times D is repeated here. So in this example, D is repeated as 61 times. So this is another features for me. Now I want to know, does the word cell appear in this document? Yes or no. So if it is yes, I'm giving value 1. If it is no, I'm giving value 0. If there is any spelling error present or not. If yes, then you should give the count of that spelling. So 13 is count, the 13 times the spelling error is present here. So what could be the feature for me? So these are the features, and these features I am representing through a vector. We'll call it as feature vector. So my features are 173, 61, 0 and 13. So these are the numerical values which I am representing through a vector, and this vector is now called feature vector. In the same way, we have a different example given here, that how to find the feature vector. Fine. So same here, you can see in this image, this is another, I want to know the price of my house and I want to take some of the features into consideration. So I'm saying that number of rooms are 3, area in square feet is 1000. So this is another feature for me. Distance to the nearest market is 1 kilometer, and gender of current owner is female. Fine. So 1 for female and 2 for male, suppose we have given. Fine. So this is a new feature vector for this particular data set. So this is called feature vector. So feature vector is what we will understand with the feature vector. Feature vector is a collection of numerical features or numerical data. Now we understood what is feature, what is a vector and what is feature vector. Now we'll talk about feature space. Now, if whatever feature vectors are available with us, if we are representing into a 1D or 2D space, then we'll call it as feature space. Clear? Now take a simple example. Suppose we have two examples here, one for classification problem and another one is for regression problem. I have certain data points. I'm saying this particular male is a spam male and this particular male is not a spam male. So I have given the data points. Data points are X and Y. And because there are multiple data points are available, so we have given X1, X2, X3 like this. And for every data point, we have label. Label we are representing through Y1, Y2. So these are my labels. Same way, for price prediction, I want to predict the price of different houses. So data points are nothing but my house and their label available. Okay, so what is the price of that house? So data points I'm representing through X1, X2, X3 and their label I'm representing through Y1, Y2, Y3. Clear? Now, these data points, now I'm representing into a 2D or 3D space, then we'll call it as feature space. Now, in the previous example, suppose I'm saying I have, previously we discussed one example about the document and we have seen the number of words are 173 and number of spelling errors were 31. So we have considered these two data points and now I want to represent into the form of graphical representation. So x-axis is representing the number of words and y-axis is representing the number of spelling errors. And I'm saying total I have 31 spelling errors in 173 words. So this became my one data point. Now in the same way, whatever data points are available with me, I am representing all the data points in the graph. So this is now my new feature space, which is representing all the data points which are present in the data. So this is called feature space. Clear? Now what we have done, we were having feature we are representing as a feature vector and those feature vectors I am representing into 2D or 3D form. So if it is in a 2D 3D form we are representing, we'll call it as feature space, or in 2D form if we are representing, we'll call it as scatter plot. So this is the different representation of your features which are available in the data set. Clear? Now we learned about the terminology feature, feature vector and feature space. Now we will discuss further about the feature selection process and the feature extraction. So many people will have a confusion that what is feature selection, why we need feature selection, what is feature extraction and all. So we will discuss in detail what exactly it is and what is the use of these terminology in machine learning. Now we'll take a simple example so that you will understand clearly. See, I have a student data set available with me, which is consisting of name, marks, address, race, religion, and attendance. Now I want to know the performance of the student and I want to know that how frequently he is attending the classes. I want to know two things. What is his performance in the class as well as he is attending classes regularly or not. So what features are required for this? Do I need race for this? Do I need religion for this? No. Only his name, marks and attendance is enough for me. Now the same data which I identify the student performance is well and his attendance is also well. Same thing I want to inform to his parents. So in that case, I need address also. So here I'm going to select four features, is name, marks, address, and attendance, and I'm removing these two features. So out of available features, I'm selecting some set of features, then we'll call it as feature selection. And feature selection is totally depends on what kind of problem you are solving. So in most of the cases, if you are considering all the features which are available in the data set, then model accuracy is on an average will be 60%. But if you are selecting only the relevant features which are required for model to give the better accuracy, then there is a possibility that model performance will reach to 80%. This is like we can say through statistics that feature selection plays a very important role in machine learning and deep learning. Now, what is the need of feature selection? Okay. See, we have all the features available with me. I have selected some of the features out of it. So I don't want this feature, I don't want this feature, I don't want these two features. So I have selected the features which are required for me in the future. So from out of all the features, we have selected some of the features. We'll call it as feature selection. Now, I hope it is clear what exactly the feature selection is and why we need feature selection. Feature selection is nothing but selecting the optimal features for machine learning model. Okay, and removing the irrelevant data or the data which is not relevant for the model, we are going to remove. So that is nothing but your feature selection process. Now, what is the importance? So I hope it is clear for you people what is the importance of feature selection. The first is reduces the curse of dimensionality. As we have seen in the previous example, we have certain features available for the student. So there are a lot of dimension are available in that data set. I don't want to carry all the dimensions or all the columns in the future. I don't want to make things more complex. So what I want to do, I want to reduce the dimensionality. I want to reduce the curse of dimensionality. So what I can use? I can use feature selection. So this is one reason why we are using feature selection. I want to reduce the dimension curse. Okay. Whenever you are doing feature selection, there is a possibility that you are minimizing the cost of computation. So in the previous example you have seen earlier we were having 5 columns. Rather than giving all 5 columns, now I'm giving 3 columns to the model. So obviously the cost of computation will be less. So definitely feature selection will minimize the cost of computation. And it also helps in learning the model because we are only giving the relevant data to the model to learn. So definitely learning will be high. And when your learning will be high, definitely there is a possibility that model will achieve good accuracy, precision, and recall. So these are the importance of feature selection. That why feature selection plays an important role in machine learning and deep learning. I hope it's clear to you. Now, what are the feature selection statistics we can use in general? So if your input variable, it always depends on what type of input variable and what type of output variable you are having. So if your input and output variable can be of categorical or numerical type. So if it is the categorical type, input and output both are categorical type, you can use chi-square. If input is numerical and output is categorical, you can use ANOVA. If your input is categorical and output is numerical, you can go with ANOVA. The same way your input is numerical and output is again numerical, you can go with Pearson or Spearman rank correlation. So any of this you can use as per your input and output variables. Fine. So there are different feature selection techniques are available in the market. You can use any one of the technique for feature selection. You can go with the filter method, you can use wrapper methods or embedded methods. Now, I hope it's clear what exactly the feature selection is. Now we'll turn our discussion towards feature extraction. So what exactly the feature extraction is? Feature extraction, what it will do, it will transform your high dimensional data into low dimension data. It means this is again try to reduce the dimension of your data set. You can take example here. You will be having a bike. Now, rather than giving whole bike to the model, you are finding what are the important features are available in this bike. So just you are segregating the important features and the features which are not important for further discussion, we will remove there itself. So this is nothing but feature extraction. So what we are doing in the feature extraction, we are finding a new set of k dimension that are combination of original available dimension. So with the help of original data, we are trying to find the new dimension data which will represent the whole data set in a better way with less dimension. Okay, so here condition is the information will remain same. You will get the same information or the combination of same information, but the dimension may be reduced comparatively. And the most widely and the most used algorithm for feature extraction is principal component analysis, which we are generally using for any machine learning algorithm.